Hello everyone, good day. My name is Jima Ade Samuel, known as Gas, and today we are here to start with business statistics. I'm here to enlighten you more on business statistics and also to teach you some key terms when it comes to business statistics. And today we are going to start with classification of data. Classification of data, which is chapter 2 under business statistics. Classification of data. So now there are some key terms here I'm going to explain to you. So I'll plead that as I'm explaining, you jot them down, then you also get more knowledge about it. So we talk about raw data. We talk about raw data. Raw data, it is the collected data which have not been organized numerically. It is the collected data which have not been organized numerically. So for instance, you go to the market, there are some oranges there, but it has not been organized appropriately or well. We say it as raw data. Or even let's use an example using IT. When we say something is a raw data, which means it has not been processed. Yes, it hasn't been processed. So raw data is collected data which have not been what? Organized numerically. We move on to arrays. Arrays. An array is the arrangement of raw numerical data in ascending or descending order of magnitude. An array is the arrangement of raw numerical data in ascending or descending order of magnitude. So when you talk of ascending, you understand from top to down, and when you talk of descending, descending is from down to up. We move on to variable. Move on to variable. A variable is any quantity or attribute whose value varies from one unit to another. A variable is any quantity or attribute whose value varies from one unit to another. A variable may be classified as I, continuous variable, continuous variable, continuous variable, continuous variable, and we have discrete, discrete variable. We have discrete variable. The continuous variable, a variable which takes all values within a given range. A variable which takes all values within a given range. And now with the discrete variable, it says a variable whose values are countable. A variable whose values are countable. Let's move on to frequency. What do we mean by frequency? It is the number of occurrence of a given value or group. Frequency, it is the number of occurrence of a given value or group. Frequency distribution. So now you have to know we have frequency and we have frequency distribution. So frequency distribution is a tabular arrangement of data. A tabular arrangement of data. This is trying to tell you that when you talk about frequency distribution, it's in a table form. It's in a table form. So a tabular arrangement of data by classes together with the corresponding class frequencies is called a frequency distribution. A tabular arrangement of data of a given value, a tabular arrangement of data by classes together with the corresponding class frequencies is called a frequency distribution table. It may be ungrouped, grouped, or categorized. It may be grouped, ungrouped, or categorical. So now we move on to what ungrouped frequency distribution. Ungrouped frequency distribution. This is the set of possible values of the variable. This is the set of possible values of the variable. Discrete bracket discrete together with the associated frequencies. When solving on group frequency distribution questions, the following steps are used. When solving on group frequency distribution questions, the following steps are used. List all values of the variable in ascending order of magnitude. List all values of the variables in ascending order of magnitude. Then the II says form a tally column. Form a tally column. All what I'm giving you is the theory aspect where I'm reading, but we will actually come to the board and solve some examples for you to get what we are trying to talk about here. So please don't worry. These are the processes when solving for ungrouped frequency distribution. It says list all values of the variable in ascending order of magnitude. 2. Form a tally column. Form a tally column. Then the III, it says sum the tallies to obtain the frequencies of each variable. Sum the tallies to obtain the frequencies of each variable. The frequencies sum up to the total number of observations. So there's an example here we are going to solve for you to get more insight about what we are doing. It says the following is a record of number of absentees per day from a factory over 21 days. The following is a record of number of absentees per day from a factory over 21 days. So we have a list of ungrouped frequency here, a list of ungrouped numerical numbers here. So we start with 3, 1, 2, 2, 2, and 0. 1, 4, 0, 1, 1, 0. 2, 4, 3, 0, 1, and 4. And we have 4, 1, 1. So these are ungrouped. These are ungrouped. And the question is say the following is a record of number of absentees per day from a factory over 21 days. So we are going to use the rules that was given. It says when solving on group frequency distribution questions, the following steps are used. So one, it says list all values of the variable in ascending order of magnitude. It says in ascending order of magnitude. But first of all, we have to draw our table and give the table's heading, each column what a heading. So now the question is saying number of absentees. Number of absentees. So we will have to draw our table. So number of what? Absentee. Of the number of absentees, we have our tally here, a number of days, which is the frequency. So it says the first question, it says arrange. It says the first step, it says list all values of the variable in ascending order of magnitude. So we would have to arrange in ascending order of magnitude. So here we have 0, we have 1, we have 2, we have 3, and we have 4 here. So we start from where? 0. So 0, 1, 2, 3, and 4. And now let's see the next step. It says form a tally column. And we have a tally here, and we all know as we're in SS, we were taught how the tally is what is done. So let's form our tally column as well. So we would have to count the number of zeros here, which is 1, 2, 3, and 4. So our tally is going to go as 4, 1, 2, 3, and 4 here. We move on to 1. So we have 1, 2, 3, 4, 5, 6, 7. So let's count 1, 2, 3, 4. The fifth one, use it as a stroke. Then 6, 7. Yes. We move on to the 2. Let's count for the 2. 1, 2, 3, 4. We have 4 for 2, so 1, 2, 3, 4. Let's move on to 3. The 3 is 1 and 2. So 1, 2. And now finally the 4. So 1, 2, 3, 4. The 4 is 4. Yes, the 4 is 4. 1, 2, 3, 4. So now we are done with our tally. We are done with our tally. So he says, the next step says sum the tallies to obtain the frequencies of each variable. The frequencies sum up to the total number of observations. So now 0 has 4, 1 has 7, 2 has 4, 3 has 2, and 4 has 4. So now let's sum it up. When we sum it up, we are getting 21. We are getting 21 as our total. So the question says the following is a record of number of absentees per day from a factory over 21 days. So now this is what we mean by the ungrouped. So you'll be given an ungrouped and you'll be asked to group them in what? In a frequency distribution. So with the ungrouped, first of all, you first have to arrange it in ascending order of magnitude. You move to your tally, you do your tally nicely, then now you come to the frequency. Now you sum up the frequency, and this is the summation of the frequency, and that's the total. So now let's move on to grouped frequency distribution. Let's move on to group frequency distribution. So we move on to group frequency. We move on to group frequency distribution. So this is a set of class intervals for the variable bracket continuous together with the associated frequency. So one, there are some key terms here I will have to explain before we move on to an example. It says class interval. It is a subdivision of the total range of values a variable may take. It is the subdivision of the total range of values a variable may take. The groups into which the values are put are called classes. The groups into which the values are put are called classes. So example of the class interval is, so the difference of this, or what sums up to this to make this is what the interval we are talking about. We move on to class limits. Class limits. These are end points of the class interval. They are the end points of the class interval. The end numbers 41 and 50 are called the lower class limit. The end numbers 41 and 50 are called the lower class limit, and the numbers 49 and 59 are called the upper class limit. So 41 and 50 are the lower class limit, and 49 and 59 is the upper class limit. So we move on to class frequency. So class frequency, it is the number of variables which fall in a given interval. It is the number of variables which fall in a given interval. As I said, these are the theories that I'm reading to you. Definitely, we are going to solve examples for you to understand what we are actually talking about here. We move on to class boundary. Please pay attention here when it gets to this class boundary. Class boundary says these are the lower and upper values of a class that mark common points between classes. These are the lower and upper values of a class that mark common points between classes. To find the class boundaries, we subtract the upper class limit of the first class from the lower class limit of the second class. To find the class boundaries, we subtract the upper class limit of the first class from the lower class limit of the second class. I know, yes, you are confused here, but listen, I'll solve an example for you to get the concept of what we are talking about. And you sit down and say, oh, yes, great, I now understand. So with a class boundary, it says to find the class boundary, we subtract the upper class limit of the first class from the lower class limit of the second class. Then we divide the results by 2. Then we divide the result by 2. We then subtract 0.5 from all the lower class limits and add 0.5 to all the upper class limits to obtain the lower class boundaries and the upper class boundaries respectively. Hence, simply, it is dividing the line between any two successive classes. Thus, the class boundary for the class 41 to 49 is given as 40.5 to 49.5. Class size. This is the difference between the upper and lower class boundaries of a class interval. Class size. This is the difference between the upper and lower class boundaries of a class interval. So with class size, it says class size equals upper class boundary minus what? Lower class boundary. This is the class size, upper class boundary minus lower class boundary. We move on to class mark or class midpoint. Class mark or class midpoint. It is obtained by adding the lower and upper class limit and dividing the results by 2. So this is the class mark and this is the class size. So as we followed a pattern for the ungrouped distribution or the ungrouped frequency distribution that enabled us solve our question, there are steps here that we are going to list down that will help us solve our question which is ahead of us. So with the first step, it says find the highest and lowest value. So when you are given any distribution, you are given any distribution and you are asked to group or the group frequency distribution, what you do is that you find the highest and you find the lowest value and you put them somewhere. You locate them and you put them somewhere. Second, you find the range. You find the range of the highest and what lowest value. So when we talk of range, the range is what subtracting the lowest value from the highest value. So this is the range. You subtract the lower value from the highest value. Then we move on to select the number of classes desired. We move on to select the number of classes desired. And selecting the number of classes desired, you follow a preamble or there's a formula to it. The formula is we use the Sturges rule. We use the Sturges rule. So you do this 1 plus 3.322 bracket log 10 n. So this is the Sturge's rule we talk about. This is the Sturge's rule. So this is formula is used to select the number of classes, where n stands for the number of data of values. So you input here the number of data of values and you input into your calculator. Then we move on to find the width by dividing the range. Find the width by dividing the range by the number of classes and rounding up. So the next one, you find the width by dividing the range by the number of classes and rounding up. Find the width by dividing the range by the number of classes and rounding up. So before this, the formula we did, which is the Sturge's rule, helps us to find the number of classes. And now this next step is telling us to find the width by dividing the range by the number of classes. So the range that we had by subtracting the lowest value from the highest value. Now we divide it by the number of classes the Sturge's rule helped us to do to find. So we move on to select a starting point. So you would have to select a starting point, which is usually the lowest value first. You select a starting point by selecting the lowest value first, then add the weight to get the lower limit. So you add the weight to the starting point, which can be the lowest value. Then when you add it, you get your lower limit. Then now we move on to find the upper class limit. You find the upper class limit. We move on to finding what the boundaries. We find the boundaries, and with all this, we are going to know how to do it with the help of what an example. We find the boundaries, then finally tally the data. Tally the data, find the frequencies, and find the cumulative frequency. Tally the data, find the frequencies, and find cumulative frequency. So we have a practical example here that we'll be solving with you as well. So the following I'm about reading the example. It says these data represent the record of high temperatures for each of the 50 states. Construct a frequency distribution for the data using 7 classes. So with this question, you could see clearly that the classes has been given already. You've been given the class to use. It says using 7 classes. So the data showing on your screen is the data we are going to use to do what? To construct construct a frequency distribution for the data using 7 classes. So first of all, as the processes was given, the steps that you are going to, it says you find the highest and lowest value. You find your highest and lower value, and per the data showing on your screens, the lower value here is 100. The lower value for this set of data is 100, and the highest value is 134. The highest value is 134 and the lowest value is 100. So when you move to the next step, it says you find your range. So you find the range for this set, and with the range you subtract the lowest value from the highest value. So your range, we have the highest value to be 134 and the lowest value to be 100. When you have to subtract this, when you subtract this, you are getting 34. You are getting 34 as your range. You are getting 34 as your range. Then we move on to finding the class. Finding the class. Now note that when the class is not stated in the question, you would have to use the Sturge's rule, which is the 1 plus 3.322 log 10 on n. If the class has not been given to you, this is what you use. But with this question, the class has already been given to us, which states that construct a frequency distribution for the data using 7 classes. So there's no need to find classes again because it has already been given to us in the question. So we move on to the next step, which says find width. Find width. So finding the width, how then do we find our width? With the width, you divide the range over the number of classes you've been asked to use. You divide the width over the number of classes you've been asked or you've calculated. And the question already gave us the classes to use, which is 7 classes. So now with the width, we are dividing the range over 7. We are dividing the range by 7. So width. So we have the range to be 34 divided by 7. Divided by 7. When we do this, we are getting 4.857. So you having 4.857, you would have to round it up to make this 4 5. You round it up to make the 4 5 here. So we move on to the next stage, which says you have to find your lower limit. You have to find your lower limit. You would have to find your lower limit. Now, how then do we find our lower limit? How then do we find our lower limit? Now, the lower limit we have here is 100. The lowest value you have here is 100. So now you having the 100. First of all, you have to select a starting point when calculating the class limit. When arranging for the class limit, you have to first find a starting point. And the starting point here, mostly we use the lowest value as our starting point. So the lowest value on the table you saw, on the numerals you saw on your screens, the lowest limit is what is 100. So now what the next step is telling us is that you find your lowest value and you add the weight to get the lower limit. You find your lowest value and you add the weight to get your the lower limit. So now we have the weight to be 5, and now we have our lowest value to be what? 100. To be 100. So we add 5 to this 100 to get us our what? 105. So after getting this 105, we continue adding 5 to each of them, and we get our what? Our lower what? Limit, and it must sum up to what? 7. It must be 7 classes. So now that we have our 100 here, we add up 5 to this 100 to get 105. We add up what? 5 to this 105 to get what? 110. We add up 5 to this 110 to get what? 115. We add up 115 to this to get what? 120. And we add up to get 125. Let's add 1, 2, 3, 4, 5, 6. And we add another one to get what? 130. So this will be our what? Our lower limit. Our lower limit for the class what's limit. Our lower limits for the class limit. And now, how then do we find our what? Our upper class limit? That's the next stage. How then do we find our upper class limit? Now, so now we finding our upper limit. We finding our upper limit. We take the second lower limit. We take the second lower limit, the figure for the second lower limit, which is the 105, and we subtract 1 from it. You subtract 1 from it. So when you subtract 1 from this 105, what are you getting? You are getting what? 104. So now after getting your what? Your 104 as your what? Your first upper limit. Your first upper limit. You add 5 to each to get your upper limit. So when you add 5 to this, you are getting 109. You add 5 to this, you are getting 114. You add 5 to 114, you are getting 119. You add 5 to 119, you are getting 124. You add 5 to 124, you are getting 129. And when you add 5 to 129, you are getting 134. So this is how to calculate your what? Your lower class limit, and you find your upper class limit. As I said, in order to find your what? Your lower class limit, what you do is that you first start with a starting point. You get a starting point, and the starting point should be your lowest value. And you know the lowest value to be 100. After getting your lowest value, which is the 100, you add your width to the lowest value. So you add it to them. You add it. So with this, the lowest value The starting point was 100. We added 5 to 100 to get 105. Then it continued. And it must sum up to 7 because in the question we said we are using 7 classes. Now, after getting your lower class limit, you move on to your upper class limit. How then do we get your upper class limit? You take your second lowest value, your second lowest class limit, your second lowest class limit, which is the 105, you subtract 1 from it. And when we subtracted the 1 from it, we had 104. After getting the 104, you continue to add 5 to each. You continue to add 5 to each to get your upper class limit. So now we are now going to put all this in a table form for you to get the understanding. So now we start with our table, and with the table, first of all, we find our class limit. And the class limit, we already did that. So the class limit, we said you start with the what? The lowest value, which is 100. Then you add up your what? Your width. And you count 1, 2, 3, 4, 5, 6. You count, you must make sure it sums up to 7. Then now, starting getting your upper class limit, you take the second lowest class limit and subtract 1 from it. You are getting 104. Then you continue to add 5 to it. So this is the upper class limit and this is the lower class limit. And now we made mention of class boundaries. As we started with this topic. Now, class boundary. So please look here attentively. How then do we calculate for our class boundary? Today, our calculator is going to help us calculate for our class boundary. So now with the class boundary, what you do is that you take your first upper class limit, the figure for the first upper class limit, then you subtract this from what? Your second lower class limit. You take your first upper class limit, then you sub. So now, how then do we calculate for our class boundaries? You take your first upper class boundary and you subtract it from your second lower class limit. You take your first upper class limit and you subtract it from your what? Your lowest class limit. So now let's do the calculation here. We have our 0, our 105, which is the what? Your lowest class limit, your second lowest class limit. Then you subtract your what? Your first upper class limit from it. So let's subtract 104 from 105. When we do that, we are getting 1. So when you subtract this from this, you are getting 1. The figure you get, you divide it by 2. So now let's divide 1 by 2. You are getting 0.5. Now when you get the 0.5, you subtract the 0.5 from the 100 here, you subtract the 0.5 from the first lower class limit, and you add the 0.5 to the first upper class limit. I repeat, you will take your first upper class limit and you will subtract it from your second lower class limit. When you subtract it, the figure you get, you divide it by 2. When you divide it by 2, the figure you get, you subtract it from your first lower class limit. After subtracting, you write your figure here. Then now you add it up to what? Your first upper class limit. So when we subtracted this from that, we had 1 and we divided 1 by 2. And when we divided it, we have 0.5. So now we will have to subtract 0.5 from this 100. When you subtract 0.5 from 100, you are getting 99.5. Good. Then you bring your what? Your dash. Then now the zero, that same 0.5, you add it to what? 104. So let's add 0.5 to 104. You get 104.5. So that is what you are going to do. That is the same thing you are going to do. So that is what is going to follow up like that. So you continue, you subtract 0.5 from this, then you add 0.5 to this, then it goes that same way. So let's go. So now this is how to find our class boundaries, and as you are seeing, our class boundaries have been arranged nicely and perfectly. So now we move on to our tally. Move on to our tally. As for the tally, very easy and simple. So now with the tally, this is where you revisit the what? The data again. You revisit the data again, and the data was presented on the screen nicely for us. So now what the tally is trying to say, what the tally is trying to say is that how many so now per the question that was given, say these data represent the record of high temperatures for each of the 50 states. To construct a frequency distribution for the data using 7 classes. So with the tally saying these are the class limits, these are the class boundaries. So the tally is going to let us know each temperature and its what class boundary also. So with 99.5 to 104.5, we had to so we write our strokes too. Then now we move on to the next one, which is 104.5, which is the range to 109.5. We had 7. So 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4. Then we stroke it 5, 6, 7. We move on to 109.5 to 114.5. We have 5, 5, 5. We have um, we have 18. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 10. 1, 2, 3, 4, 5. This is 15. And we have 1, 2, 3. So making 18. Making 18. We move on to 114.5 to 119.5. With that one, we have what? We have 13. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, making 13. We move on to the next one, which is 119.5 to 124.5. With that one, is 7. So 1, 2, 3, 4, 5, 6, 7. We move on to 124.5 to 129.5. We have 1 for it. And the last one, which is 129.5 to 134.5, is also 1. So now we come to our frequency, and with the frequency, we state this in numerical form. So with the frequency, we state this in numerical form. So we have 2, we have 7, we have 18, and we have 18, we have 13, we have 7, we have 1, and we have 1 as well. So now we move on to the last one, which is the less than cumulative frequency. we have the less. So we move on to our less than cumulative frequency. But before we move on, this place is supposed to be 8, not 7. Sorry for that. Supposed to be 8, not 7. So before you continue, you have to make sure that when you add up your frequency, it must sum up to what? The number of states given in the what? In the question. The number of states given in the question is 50 states. 50 states. So when you sum up this, it must sum up to what? 50. Must sum up to 50. So with the less than cumulative frequency, you have to first have it in mind that when we hear less than cumulative frequency, it's starting from the top. It's starting from the top. So what you do is that you maintain this your 2, then this 2 you add it to your 8, getting 10. Then this 10 you add it to your what? 18 here, getting what? 28. Then this 28 you add it to your 13 here. You add it to your 13 here, getting 41. Then it follows. So this 41, you add it to your 47, getting what? 48. Then 48 to your 1, getting what? 49. Then 49 to your 1, getting what? 50. And you see that it's in order. It's in order. But when you hear more than cumulative frequency, that one you start from the bottom. Like the way we did for the first one, starting from the less than, starting from the top. You do the same process, but that one you start from the what? Bottom. So